Hello and welcome to FD Classes. In this video, we are going to define and we are going to understand what polynomial is all about. Polynomial, to understand first of all what is polynomial, we need to know this thing that in mathematics we study polynomial in a branch called algebra. Algebra is the branch of mathematics in which we study about polynomials. What is algebra? First of all, it is a branch of mathematics in which we study about variables. We study about variables. So algebra is that branch of mathematics in which we study about variables and their relationship and their relationships. So in algebra we study about variables and their relationships. And next to that we need to understand here that what is a variable. A variable is a symbol with varying value that varies symbols. Any symbols which has different value in a different situations are called variables. For example, usually these are letters. These are small or uppercase letters like XYZ. Mostly XYZ are the mostly used variables. Next term that we need to understand here, that constants are the opposite of variables. And we know, as we defined it here, variables are unknown values, but these are constant are fixed values. The values which does not change are called constants. These are numbers, 1 2 3, like that. These are the numbers. Now if we have, in case, now what we need to understand here, that what polynomial is basically polynomial. Now I'm going to define polynomial. Before that, let me define expression or algebraic expression. Algebraic expression is a statement in mathematics, statement in math, containing consisting of variables, constants and operators. So an algebraic expression is basically a statement or the sentence of English in which consists of variables, constants and the operators. For example, 4x plus 1. It is an algebraic expression because it contains variable x. 1 is the constant here. And this number which is multiplied with the variable is called the coefficient of this variable. 4 is the coefficient of x. Coefficient. The number which is multiplied with the variable is called the coefficient of it. Now let me one more example of, for example, minus 2 4z plus 1. This is also an algebraic expression because we know here we have z as a variable, x as a variable, 1 as a constant and z as a coefficient of z. 4 is the coefficient of z and 4 is the coefficient of minus x raised to a minus 2. So this is how you know what algebraic expression is. So what is polynomial basically? Why I'm defining these two things, these so many things to you people? Because I want you to differentiate between polynomial and the algebraic expression. Now, what is polynomial? It is basically also an algebraic expression. It is an algebraic expression. Remember, it's an algebraic expression in which, but there's a condition. Condition is like that, in which the power on variable on every variable the power on every variable is a whole number. Remember this thing, it is very important point. That algebraic expression in which the power on every variable is a whole number, that very time we call that as a polynomial. For example, it is usually represented by p of x and read as polynomial of x in the variable x square plus 1. This is a polynomial. Why it is a polynomial? Because we know here at the x we have 2 as a power. The power on the variable is 2 and 2 belongs to whole numbers, right? So it's a polynomial. But like this is also a polynomial. Why it is a polynomial? Because we have, in this variable we have 2 power and here we have 1 power, and we know both 2 and 1 belongs to whole numbers, so it is a polynomial. This particular expression is a polynomial. Next, for let me give more example by which we can differentiate this thing. it is z here, y plus 4. This is also an expression, algebraic expression, because it contains variables and the constant terms and all these things. Is it a polynomial? Now what you need to check, whether the power on the variable is whole number. Here we have power 1, here we have power 1, here we have power 1, here we don't have any power, it is 0. Actually the power is 0 because we can write x raised to power 0 here. You don't need to remember this. So but what we see here, that the power on the variables, on every variable, is a 1, and 1 belongs to whole numbers, so we can say it is a polynomial. So all such types of equations, algebraic expression in which the power on the whole, all the set of variables present is a whole number, that very time we call that algebraic expression as a polynomial. Now what we need to define here, one more thing, that let me give certain example by which you can differentiate that algebraic expression, how when we can say this is not a polynomial. For example, see, -1 plus 4x square, this plus 4, this is an expression I told you because it contains variables and the constant terms here and the operators plus are here. Now what you need to understand here, that you can see here in the first term, the power on the variable is -1, here power is 2, right? This 2 belongs to whole number, but this -2 we don't know, does not belong to whole numbers, so we can say all the powers does not belong to whole number, therefore this particular term is not a polynomial, not a polynomial here, right? So next what we are going to do here, certain examples. If this a polynomial, apparently it looks like a polynomial, but you need to remember this thing here, that it is not a standard form of the polynomial of any expression. In the standard form of expression, this variable has to be at the top, not at the bottom, and we know the power here is 1. If we are going to take it at the top, then it will be x raised to power -1, because we know 1 raised to power -1 will be x raised to power 1, or x raised to power -1 will be 1 by x. If you are taking this down, then you have to take this sign as a positive here. If it is negative down here and you are going to put it up there, then it is positive, it is sign. So similarly here it is x raised to power 1, it will be x raised to power -1 at the top, then we have +1. Now you can see here the variable is -1, it does not belongs to whole number, so we can say it is not a polynomial. One more definition of polynomial. So one definition which I gave, which is a standard definition, that polynomial is that algebraic expression in which the power on the all the variables is the whole number, that very time we call this algebraic expression as a polynomial. Next thing, polynomial is basically made of two words, poly and nomia. Poly means many. At times you may have heard this, but this is not a particular, this is not authenticated definition of the polynomial. Many terms we say, many terms is also called a polynomial, but as now we are going to see the classification of polynomial. Classification, let's give the classification of polynomial. Classification of polynomials. Polynomials are classified based on terms, based on number of terms. First classification which we give in polynomial is based on number of terms. First, if the term is one term polynomial, for example 4x is one term, and with that very time we call this as a monomial. That polynomial containing only one term is called a monomial. Two term, if we have two terms, for example 4x plus 1, then we can call as binomial. If we have three terms, then we have like 4x plus 4z plus 1, we have three terms, this and this, we call it as a trinomial. Next we have 4. If we have 4 or more terms, we have general name for every polynomial, then that is polynomial. All the term, or x after 3, whatever the number of terms will be, 4, 5, 6, 7 or 8, any number of terms will be called as a polynomial in general. Now second classification based on power based on degree on a variable. Now first of all you need to understand what is degree. Degree is nothing but the highest power. Highest power is called a degree. For example, x square plus x plus 1. Here we see 2 is a power, here we see 1 is a power, here we don't have any power, it is 0 here. Now the highest among all the powers, it is 2 here, so degree is 2, right? So degree is nothing but the highest power. Now in a polynomial, if the degree is equal to 1, that is like this, x y plus z. All the powers are 1 1 1. So we see, if in a term, if in a polynomial the highest degree is 1, we call is a linear polynomial. Linear polynomial is that polynomial in which highest degree on the variable is 1. Now if the degree on the variable is 2, we call this as a quadratic polynomial. For example, x square plus 1, this is quadratic polynomial. Now if the degree is 3, if degree is equal to 3, degree equal to 3, we call it as a sorry, it is cubic polynomial. For example, x cube plus 1, here the degree is 3, so it is called a cubic. Next we have biquadratic. That doesn't, we don't study it in lower mathematics. Let's remember up to 3 power. Next, for example, let me ask you a few questions. For example, this is the, I'm writing this here. I'm asking, it's the X here. I'm asking you a question out of this. Based on terms, what is this named as? This polynomial. Give me the name of this polynomial based on number of terms. And we know how many terms we have: 1, 2, and 3. So 3 terms, right? 3 terms. So we know what is the 3-term polynomial called as trinomial. So this is the trinomial. But based on the power, and what is the degree here? Degree is 2, because we see degree here is 2. So based on a degree, it is quadratic. So this polynomial is also called quadratic as well as trinomial. This is quadratic polynomial as well as trinomial. So we can name a polynomial in two terms. First, based on the number of terms, if the number of terms is anything, we name it according to that: by monomial, binomial, trinomial, then the polynomial for the general terms. If the power is 1, that's called linear. If the power is 2, that's called a quadratic. If the power is 3, that very time we call it as a cubic. Next, we don't have any particular name for any term, right? Now see, now this polynomial, generally we represent it for p of x. It is ax plus ax ax. If it is a quadratic, then ax plus bx plus c. It is a general quadratic polynomial which we have to study most of time. This is how we can, if you are talking about a linear polynomial, then it is ax plus b. This is general linear polynomial. Similarly, you can name any general polynomial according to the need. You can, write it accordingly. Now the thing that is important here is the zero of a polynomial. Zero of a polynomial. What is the zero of a polynomial? It is very important topic. Zero of a polynomial. Remember, let us define it algebraically first of all. What is the meaning of zero of a polynomial? For example, we have a polynomial p of x. Now obviously it will contain a variable x, because it is, that's why it's called p of x. If it is containing variable z, then we will name it p of z, p of z, p of y, p of something. This something which I am writing it in braces here is nothing but the variable present in the polynomial. So here we have polynomial x. Now zero of a polynomial is nothing but it is the value. Remember, it is a value of variable, value of the variable which which makes p of x equal to 0. Remember, it is the value of variable, it is the value of this x here, which will make this whole polynomial, whatever the definition of the polynomial will be here, the expression will be here. What is the value of this particular variable here, so that if I put that value in this expression, it will make it equal to 0. Let me give an example. For example, p of x equal to x plus 4. This is a polynomial, and it's a linear polynomial, a binomial as well, right? Now if somebody will ask you, what is the zero, find the zero of this polynomial. Now you have to find value of this particular variable x here, so that that value when you put it here, it will make it equal to 0. And we know here we can see, and just think about what should be the value of x here, so that this whole will become 0. Remember, it is minus 4, right? Because when you put x minus 4 plus 4, that will be equal to 0, right? So this value of x which made this p of x equal to 0 is called a zero of polynomial. Remember, it is not just a zero, sometimes it may be zero, but zero of a polynomial is basically the value of polynomial which will make it equal to 0. Now, what is the geometrical meaning of this? Geometric meaning of zero of a polynomial. Zero of a polynomial. It is simple here. Remember, the zero of a polynomial is nothing. For example, if the graph is like this, I'm using a graph like this. Zero of a polynomial is nothing but the values of x coordinate where it intersects the x-axis. This is x-axis here and this is y-axis here. So how many zeros? So basically zero is nothing but the places x coordinates where it intersect y axis. For class 10th, this is how you can do exercise 2.1. There you see, for example, if I have number of lines, for example, I have number of graphs. For example, this is the graph first and I'm drawing like this. So how many places it is intersecting x-axis? Here it is intersecting. So how many zeros? Number of zeros is equal to 1. It has only one zero because it is intersecting x-axis only at one position. So how many number of zeros is 1, and this value, particular value of x is called, it is 0. So if I'm drawing another graph like this, how many zeros we have? 1, 2 and 3. For example, this is another graph. So how many zeros I have here? 1, 2, 3, 4, 5, 6. For example, this is also a graph here. I'm drawing it and I'm drawing a line parallel to the x-axis. We don't have any zero here, no zero, because it is not intersecting x-axis. Because we know what we defined as a zero, what we said when we defined zero of a polynomial, we said it is the value, it is the x value where p of x will be 0. For example, we know where we have p of x is 0. P of x is basically y coordinate, the value result is y actually. So we know x coordinate, y coordinate has to be 0 for a 0 of polynomial y of x equal to 0. So we know y is 0 only on x axis. So all the points where it intersects, where this particular graph of particular p of x intersects x axis are nothing but the 0 of the polynomial. And remember, number of zeros is equal to how many number of is equal to degree of polynomial. For example, if x is 2, then how many zeros we have? 2. Whether they are real zeros or sometimes it may be a complex number, but the number of zeros is always equal to the degree. If x raised to power n is a degree, so number of zeros will be n. Whatever the degree will be, the number of zeros will be that very particular value.